This is Note-Taking Guide 8.3 for Mathematical Decision Making for Life. Today we're going to talk about something called biconditional statements. And then we're going to talk about the symbols that go along with these kinds of theories that we've been talking about. So let's just start with some examples of what we're talking about today. So it says the negation of a statement is the opposite of the original statement. So if your statement 1 is the ball is red, then the negation of 1 would be the ball is not red. So if you'll notice, we just took what was happening in the first one, it was red, and we changed it to not red in the second one. All right, statement 2 says the cat is not black. So to negate that, then we're going to actually say the opposite of not black, which would be black. So the cat is black is the negation of statement 2. Notice that in statement 2, it's already negative, so the negation is actually positive. So we're really just doing the opposite statement of what the original says. So a biconditional statement is a statement that contains the phrase if and only if. Writing a biconditional statement is equivalent to writing a conditional statement and its converse. So really what that's saying is it works the same frontwards as it does backwards. So here's an example. The ceiling fan runs if and only if the light switch is on. That really means the same thing as these two statements at the same time. So if the ceiling fan runs, then the light switch is on. If the light switch is on, then the ceiling fan runs. So the if and only if part of the statement means that it happens the same forwards as it does backwards, and it still is true both directions. So that's what that if and only if statement means, and it's called a biconditional statement. All right, so here's an example. Write two statements as biconditional statements. So here's our two statements. If Mary is in theater class, she will be in the fall play. The second statement, if Mary is in the fall play, she must be taking theater class. So what actually is the biconditional statement for that? That would be, again, it has to be using that if and only if statement. So we're going to say, Mary is in the theater class if and only if she is in the fall play. You could also say it the opposite direction. You could say, Mary is in the fall play if and only if she is in the theater class. You could do it either direction. I did it the first way when I wrote it down. So give me just a second. I'm going to write this down for you, and then you can copy it to make sure you have it correct. All right, so again, what I wrote down was that biconditional statement that says Mary is in the theater class if and only if she is in the fall play. And again, that really just means that happens both directions. So take a minute, pause the video, write this down, and then let's go on to the next problem. Example 2 says write the biconditional as a conditional and a converse. So I'm actually writing two different statements here. Again, a biconditional statement just means it happens forward and backwards the same. So that's what I'm going to do. I'm going to take this and write it the first direction and then flip it and write it the second direction. So our statement says you scored a touchdown if and only if the football crossed the goal line. So our first statement would be you scored a touchdown, or if you scored a touchdown, then the football crossed the goal line. And then the second one would be, if the football crossed the goal line, then you scored a touchdown. So you have it frontwards and backwards with those if-then statements instead of the if and only if statements. So I'm going to pause my video, write those down, and then you can just copy those off of the video here. All right, so here's my two statements. Again, the first one is if you scored a touchdown, then the football crosses the goal line. The second one, if the football crosses the goal line, then you scored a touchdown. So take a minute, pause the video, write those down, and then let's move on. All right, example 3 here says, use the information about volcanoes to determine whether each biconditional statement is true or false. If false, provide a counterexample. So really what we're doing is we're using this chart over here to see if these two statements over here are true or false. So just to read what this says right here, it says solid fragments are sometimes ejected from volcanoes during an eruption. The fragments are classified by size as shown in the table. So it's called ash if it's between a diameter that's less than 2 is called lapillary if the diameter is greater than or equal to 2 and less than or equal to 64. And it's called a block or bomb if the diameter is greater than 64. So let's just read the statement and see what it says. It says, a fragment is called a block or bomb if and only if its diameter is greater than 64 milliliters. So let's look at block and bomb over here. Block and bomb is right here. And it says that the diameter has to be greater than 64. And that's exactly what our statement says, greater than 64. So we're going to just call that statement true. That one works for every number greater than 64. The second problem here, though, says a fragment is called the lapillary if and only if its diameter is less than 64. So let's look at a lapillary over here, and let's see if we can be any number less than 64. Well, on our restrictions over here, it says that we have to be between 2 and 64. So what if my diameter is 1, which is actually less than 64? If my diameter is 1, is it going to still be called a lapillary, or is it going to be called something else? And it actually would be called ash then. So this one is actually false, and that diameter equals 1 is what we would call a counter example, an example that proves that the statement is false. All right, we're going to shift a little bit here, and we're going to start talking about some symbols that go along with our statements. So the first thing we're going to do is, every time we're dealing with statements here, it's easier to call them a variable. So in this example here, when we're doing symbolic notation, we're going to assign letters to represent statements. So for the next several examples, every time we see P, it means it is cold. Every time we see Q, it means it is snowing. And every time we see R, it means the sun is shining. So over here, this first symbol that we're looking at, this is called the AND symbol. So we're going to do P and Q. So P is it's cold, and Q is it's snowing. So our statement is it is cold and it is snowing. Because AND is the symbol. So what we're really doing is we're just connecting those two statements together with the symbol that it gave us. So then we're doing R and Q. R is the sun is shining. And Q is it is snowing. So the sun is shining and it is snowing. So that's how we do the AND statement. We put them together with the AND in between them. Okay, this next little symbol right here, this is called the negation. I like to think about it as the opposite. We say not when we are using that word. So this is called not P. This is not Q. This is not R. So if we're doing not P, the statement for P says it is cold. So we're going to say it is not cold. The statement for Q is it is snowing, so we're going to say it is not snowing. And then the statement for R is the sun is shining, so we're going to say the sun is not shining. That was hard for me to say. So that is how we negate those or do the nots on our statements. Okay, the next symbol is the symbol that represents OR. So P or Q. P or Q would be it is cold or it is snowing. And then R or Q would be the sun is shining or it is snowing. Okay. All right, let's go on to the next problem. When we see an arrow as a symbol, the arrow connects the hypothesis and a conclusion. So when it says P arrow Q, it says P implies Q, or if P, then Q. So we're really using that to write if-then statements. So our P statement says it is cold. Our Q statement says it is snowing. So we're going to say if P, then Q. So if it is cold, then it is snowing. For the representation of the arrow. Okay. So then the double arrow, the arrow going both directions, this is an if and only if statement. It means if and only if this can happen. It's a biconditional statement. So if we're doing P, if and only if Q, then it will be it is cold if and only if it is snowing. For that biconditional statement. Okay. So now what we're going to do is we're going to take it and we're going to try to put it all together in a couple of examples. So logically, P, if and only if Q, is the same as P implies Q, and then and Q implies P. So let P be the car is running and let Q be the key is in the ignition. Write the converse, which is Q implies P. So we would say the key is in the ignition if the car is running, because we do the opposite. I wish that this program had a way I could type this on here. My handwriting is really bad when I have to write on this iPad. So sorry about that. The second one says write the contrapositive, which is not Q, if then, not P. So we're going to write a statement for that. And that's going to be, when we write that one out, that one's going to be, if the key is not in the ignition, then the car is not running, because we're not Q, we're not P, and then we're implying with the if then. So again, I'm just going to say it this time. You guys can write it down. It says, we're going to say if the key is not in the ignition, then the car is not running. So if the key is not in the ignition, I'm just going to abbreviate, then we would say then it's not running, because we have to do the opposite of both of those. So take a minute and write that down nice on your paper. But it says if the key is not in the ignition, then the car is not running. Okay, the last one says use the statement. If an animal is not a dog, then it is not a poodle. Identify the hypothesis P and the conclusion Q. So the hypothesis is if the animal is not a dog. So we're going to say animal is not dog. And then the conclusion is then it's not a poodle. So we'll say not poodle. And then we're going to do what it asks us to do. So it says not Q, not P. So not Q would be the opposite of not a poodle. So we're going to say if it's a poodle, and then we have to negate P. So it already was up here not a dog, so we're going to say it is a dog. So if it is a poodle, then it is a dog, because we had to do the opposite of both of them, and then the if-then statement for it. So the last page here just reminds you what the symbols mean and shows you how to, remember that. So a conditional statement is if P then Q. It's like this with symbols. Converse statement is if Q then P. It's like this with symbols. It's just a cheat sheet to remind you which one is asking you to do. Thanks for watching the video. Good luck on your homework. Let me know if you have any questions.